Today we can start a new chapter in chemistry, classification of elements. Classification elements you learned from class 10th, and this chapter is just a continuation of that. Last chapter of class 10th is about classification of elements, Dobereiner triads, Euler law of octaves, Mendeleev periodic table, and modern periodic table you learned in detail last year. So just go through it again. And today we are starting from modern periodic table. And modern periodic table, an idea about modern periodic table is very important for learning chemistry. That's why I selected this chapter first. So please listen carefully and understand it. Here you can see a simple picture of modern periodic table. A modern periodic table almost look like this. In modern periodic table, elements are arranged in the increasing order of atomic number. Atomic number means number of protons. Here the first element is hydrogen. Atomic number is 1. Second element helium. Atomic number is 2. Lithium atomic number 3. Beryllium atomic number 4. Boron 5. Carbon 6. Nitrogen 7. Oxygen 8. Fluorine 9. Neon 10. That means the elements are arranged in the increasing order of atomic number. Atomic number means number of protons. So according to modern periodic table, the fundamental property of element is atomic number. Who discovered modern periodic table? Do you have any idea about it? Yes, Moseley. So this periodic table is also called Moseley's modern periodic table. Clear? Already is that elements are arranged. In modern periodic table, elements are arranged in the increasing order of atomic number. So modern periodic laws state that physical and chemical properties of elements are periodic function of their atomic number. I repeat, modern periodic law states that physical and chemical properties of elements are periodic function of their atomic number. How many groups and periods in modern periodic table? What do you mean by group? What do you mean by group? Group. What is the meaning of group? And what do you mean by period? Did you remember it? Group and period you learned last year. Related to Mendeleev periodic table, modern periodic table, you learned group and period. What do you mean by group? Vertical columns are called groups, top to bottom. Like that, how many groups in modern periodic table? In modern periodic table, there are total 18. So total groups are 18. Like that, 18 vertical columns are present in modern periodic table. How many periods? What do you mean by period? Horizontal rows, left to right. How many periods? The first period, second period, third period. Like that, how many periods? Total 7 periods in modern periodic table. 7 periods equal to 7. Clear? Then here also 2 periods, and these 2 periods are continuation of 6th and 7th. So in detail I will explain later. Okay, then first period contains how many elements? First period contains just 2 elements, hydrogen and helium. Second period contains 8 elements. Third period contains again 8. And the fourth period contains 18. And what about fifth period? Fifth period again 18. Now the sixth period Sixth period contain 32 elements. Sixth period contain 32 elements. Clear? And last period and sixth period, and this is this continuation of sixth period, contain how many elements? 32. And last period, seventh period, few elements are here, remaining elements down. And seventh period is incomplete. It is more than 32. Why it is incomplete? Because seventh period elements are radioactive, highly unstable, and newly discovered elements are adding into seventh period. So seventh period is considered as incomplete period. Okay, this is about a simple picture of modern periodic table. Okay, and it is a modified version of Mendeleev, and the first classification of periodic table is Dobereiner, based on law of triads, then Newland law of octaves based on octaves, Sarigama Padanisa theory, and Mendeleev periodic table, and finally the modern periodic table. And the ancient classification very clearly you learned from class 10th, so I am not going to repeat it again. So we can start directly the syllabus. So this modern periodic table, number of periods, number of groups, each number of elements in each periods, and modern periodic law, all are important. Okay, nomenclature or naming of elements with atomic number more than 100. That is, for more than 100, IUPAC suggested some rules for writing their names, because especially atomic number more than 100 coming to radioactive or highly unstable elements, and newly discovered elements also coming to this category. So for writing this highly unstable element or for newly discovering element, IUPAC suggested some rules. Let's see the rules. For example, if element having atomic number 101, how to write the name? Use this table for writing that name. If 1, use the symbol UN. For example, if you want to write name of element atomic number 101, how to write? For 1, UN, write UN, and for 0, write nil, un-nil. Clear? Then for 1 again, write un. So un, nil, un. Then add IUM. So what is the name? Un-nil unium. Understood? And how to write name of element 102? Atomic number 102. For 102, the name how to write? Again for 1, un. For 0, nil. Then 2, Bi. So here you can write Bi. Okay. Then add IUM. But here you can see already one I here and an I is here. So IUPAC suggested that if 2 I is coming, we can leave 1 I. So what we can write? Instead of by IUM, we can write Bayum. So name is un-nil Bayum. And in short, in simple form how we can write? For un, the symbol is U. So you can write U. Then nil, N. For by, B. So symbol of element 102 is UNB, and the recommended name of IUPAC is un-nil Bayum. Okay. Then actually 102 is also called nobelium. Okay, another name suggested by IUPAC is nobelium, and nobelium is not based on any rules. You know, nobelium is related to the name Alfred Nobel. Clear? So it's related to that. So like that, each element there are 2 names. One is recommended by IUPAC by using rules. Second is like a common name. Okay. Now we can write more examples. For example, so I'm not rubbing this table. Okay. 104. 104. How to write 104? For one, un. For 0, nil. For 4, code. So un, nil, code. And what I said, add IUM. So what you will get? Un, nil, codium. This is the name of element with atomic number 104 according to IUPAC rule. And what is the symbol? What is the symbol of this? 1, U. Nil, N. Codium, Q. UNQ. UNQ is the symbol of this element. And very important, this element have one more name. That one more name very familiar to you. The name is Rutherfordium. Can you see here? Rutherfordium. Rutherfordium. So 104 element 104 is also called Rutherfordium. So Rutherfordium is also a name suggested by IUPAC for giving the respect to Rutherford. Who is Rutherford? A scientist discovered protons and structure of atom. So two names are used. One is related to some scientist names, some countries. Second one is based on some rules. Okay, so first and this name is called recommended name of IUPAC, and this is IUPAC name, recommended name and IUPAC name. Okay, I think I will give one more example. Okay, remaining you can write like a homework. Okay, it's not difficult one. Okay, so we can rub this one. Write 105. How to write? For 1, what you can write? Do you remember for 1? Un. Plus. For 0, nil. Plus. Actually it is like plus, then we can add together and write. Un, nil. Plus for 5. 5 is pent. Plus IUM. So what is the name? Nil pentium. And symbol is U, nil, N, P, UNP, nil pentium or UNP. Clear? Now we'll write one more example. 103. 103. How to write? For 1, un. 0, nil. 3, try. Then plus IUM. But see here I. So IUPAC suggested that we can leave one I from here. So leave one I. Un, nil, trine. So here I wrote only one I. Un, nil, trine, and symbol is UNT. And this name element is also called Lawrencium. Okay, Lawrencium. Okay, Lawrence is related to a name of scientist. So there are two names. One is IUPAC. Okay, this is called IUPAC official name, and this is IUPAC. Sorry, this is IUPAC recommended name. So I think you got a picture about the rules related to elements of name of elements of atomic number more than 100. Now write two examples and take it as a homework. I will give two examples to you and write in your notebook. Find name of following. Okay, elements with the atomic number 108. Second, elements with the atomic number 107. Okay, so find out the answer, so it will help you to revise the topic one more time. Okay.